Acunetics helps thousands of organizations secure their websites and web applications across the globe. Whether you're a one-person team ensuring the security of a few websites or a large organization interested in automating your web vulnerability assessment and management, Acunetics is here to help.
Hello, everyone. Thanks for joining. Welcome to the OWASP Global AppSec 2020, the virtual edition. My name is Ismael Goncalves, and this presentation is called Start Me Up Safe. Let's go over that mandatory slide, who I am. I've been working in the information security industry, specifically application security, for about 13 years. Along with my career, I've played lots of different roles, such as developer, building security solutions to companies, pen tester, performed lots of code review, consulting, and also in different industries such as government and the private sector, especially the finance sector. Currently, I'm a senior security consultant in F5, and I'm also a cybersecurity advisor in a startup related with social network. I'm also a former OWASP chapter leader down in Brazil. I am Brazilian, and I don't know how to dance samba. I've made contributions to some of the OWASP projects, such as the OWASP testing guide, the OWASP cheat sheet, and also the OWASP Zap proxy communities. I'm also a bug hunter in one of known bug bounties initiatives, and I share things with the community on my GitHub /Ismael Goncalves, and also I blog when there is some specific time at the sharengsec.net. So, start me up safe. When I came up with this presentation topic, I was thinking about the small startups, especially they come up with like great ideas, and those small companies, and it's time to build their solutions. And I was thinking, they might be struggling a lot to add security on top of the products, and I was thinking how they could do better. How we could, considering all the challenges that we'll be seeing, those kind of companies that they suffer, how they could do better and starting inserting security in their process since day one. And there are a couple of numbers here quite interesting. There is this research from Vodafone that says that 80% of the high growth companies see security as a business enabler. And what does that mean, see security as a business enabler? That means that those leaders from those companies, they see security as a vehicle to increase the business partnership, to retain customer loyalty, and to be ready to expand the markets, right? And also be in compliance with regulations and laws to allow them to expand their business and expand their partnerships in general. However, 60% of the smaller business companies, they are feeling poorly informed about security. And this, of course, is security in general. Imagine now application security, which is a quite complex topic. As you can see, we have a whole conference dedicated to AppSec. Another number that caught my attention is the Verizon data breach investigation report. So in 2019, out of all the incidents that they investigated, 28% of the incidents of the data breach, they were from small business. What does that mean from those small companies? That means that they are getting targeted. Either they're getting attacked directly on a target attack, or if there is something in the wild just happened to hit their servers, their applications, and breach their systems. And that is not a surprise, right? If you think that, okay, I have this small company, I'm just starting that, I have this only application, still not in production. If you put the server in the cloud, it's just a matter of minutes for the first HTTP request to start hitting your web server, probing for known vulnerabilities. And of course, if you have a component that is vulnerable, those automated attacks will basically breach into a system easily. And there are some more numbers that is impressive. As a bleeping computer, over 300 millions of records leaked from startup. And on the top of everything like this, there are laws and regulations that you'll be looking to comply, right? Especially as their business grows. And I could name a few of them, like the GPDR and the LGPD in Brazil, the GPDR in Europe, so related to privacy concerns, and also the PCI DSS. And finally, there is the cultural aspect of inserting security early. Then it's a chance for you to bake security into the culture of the company. Let's have a look. How do you build your solution, right? Traditionally, as you had a great idea, so you come up with this, and this is how security, like a software development, traditional software development looks like. And there was a really funny situation today when I showed this slide to my wife, and she read, "Where's the security sit here?" She pointed right away to testing, even if she's not in IT. And I said, no, that's not the that's not the right place. But lots of people are putting security only at the time they'll be releasing the product. It's especially those small companies when they are about to make big integrations or do business with some partnerships. They call the external company and say, "Hey, I'm about to integrate this product that I built here with this big credit card acquirer," and they come with this big list of security tests that I need to run, and I don't know anything like this. Can you help me? Then you're paying them, and they'll likely find lots of security holes in your system. That is not the correct way. If you look at this software development lifecycle, there are lots of security that could be done across all those specific phases. Security requirements, you'll be talking about at the requirement phase. You'll be taking into consideration regulatory requirements. So just thinking about the PCI DSS, for instance, if you're willing to deal with credit cards in the future, you might be subjected to that. Then you come to the design, and you need to perform some specific threat modeling to understand the risks that your application and your business have, and design a security review on the top of that. So time of coding. There are a couple of activities, security activities that exist at the coding phase, let's call it like this. You'd have an approved list of tools and libraries. You'd be performing static analysis, so looking for the code for the vulnerabilities. You'd be following secure coding practices, how you do input validation, how you prevent secret injections, don't store credentials in the source code, etc., and also some peer review. Those are all security activities across the software development lifecycle. Then you do on the testing phase, right? On the top of all the regular tests, unit tests, you'd have some security tests like dynamic analysis, static analysis, and dynamic analysis, very well known as the vulnerability scanners. You'll be running on that specific phase of the security test. Then the time of release, you want to do the pen testing for sure. You want to make sure that everything looks good. However, you still need to plan on an incident response plan, and you need to make sure that the infrastructure that is supporting your application is hardened. So it follows hardening guides as well. And finally, when you release the product, there is still the incident response activities. You need to do continuous security testing because new vectors might arise, and you might have left a component in production that you're no longer using, or they are an outdated component. And vulnerability monitoring. There are new vulnerabilities. When you code the software, there was no vulnerability for that specific, let's say, third-party component you're using, but now there's a new vulnerability out there, and people are starting to exploit that in the wild. So how do you get information about that? So as you can see, there are lots of things here to do. And of course, when you're thinking about those small companies, there are even more challenges with the application security. Even in the big ones, we have those challenges. Imagine on a very small company with a handful of developers, a very small team. Sometimes you don't have a person or an InfoSec team, and imagine an AppSec team or an AppSec person, right? Some of the challenges, like the perception of security as a bottleneck. This is one of the things that the business says, okay, so I'm putting all of those activities. If you look at the previous slide, so many work to do. This will slow down my process. This will slow down the process and slow down the releases to go to the market, right? You might have lack of funding, sponsorship, or lack of awareness. It's a small company, you have a great idea, but you're not, let's say, especially those companies that are started by some IT folks, so they might not have the proper education in terms of security. They might not be aware of all of those issues. And then the lack of specialized security knowledge and resources, right? If you're thinking about, for instance, threat modeling is a very specialized thing. And lack of resources. You don't have people to carry all of those activities. And also lack of overall strategy. If you're thinking about those very small companies and thinking about the startups, which usually are in some sort of risky business, they might change overnight their business direction. With the COVID, we saw lots of examples like that. And last but not least, the business pressure to go to the market, right? A small company needs funds, right? Needs money. So they want the product to go to market. This way they basically can start gaining some revenue and gain more customers and maybe looking for more investors and other partnerships with more bigger companies and so on. So lots of challenges here to address. Then I thought, considering all of this situation, how one could start and where, especially if you look into this previous graphic here and all those activities that involve delivering a secure solution, how could one start these and where they should start? Which one is more important than the other? I don't think there is one size fits all solution. In my opinion, this might vary. And I thought about 3 items that some of the companies they could start, and they would be using open source and free resources, and you could start getting into the security right away since day one and improve the overall security culture of the organization. Let's get into them. Then a great start is security requirements. Security requirements is the foundation of any secure software. It's the backbone of any secure software. It's a quality attribute to increase trust on a solution, on a specific system. And the security requirements, they should be considered in all phases of the software development. What do I mean for that? By that? It can be described as a non-functional requirement. Imagine, for instance, a security requirement is the system should prevent SQL injection. That is a clear security requirement. Or the API should have a mechanism that throttles IP addresses after 10 requests per second. Those are also some security requirements. They could be developed either, let's say, if we're doing a more traditional waterfall model, which usually people, I think they're no longer using that nowadays. They're more into agile ones, and it could be part of your sprint. Basically, it could be baked into the acceptance criteria or into your definition of done. And also, it can be used to derive security tests and verification because you have the security requirements clearly stated. As I said, the API needs to support a maximum, the API needs to throttle any client that does more than 10 requests per second. So that's a clear security requirement, and you could bring this to the security test and security verification. How do you do that? You should use industry best practices, combine that with some regulatory that you need to meet, and to meet some specific business requirement at the end. Also invest early to collect benefits in the near future. NIST says that fixing a bug or a weakness after the software is in production costs up to 30 times than fixing that specific bug when you're doing in the beginning, right? And I really like one example of a software that I've audited in the past, and I call like the MD5 case to illustrate a little bit of that. And basically, that specific system, I've performed penetration testing and a code review for that system, and I found out the users were having their passwords stored using the MD5 hash, which is widely known as not secure and not good for that use case. And the thing here is, when I brought this issue to the customer, they acknowledged the issue, and basically we discussed a little bit of how it would be complex to fix that in terms of time and in terms of money. They outsourced the development, so they need to brought the external company to fix the thing for them. And as you can see, if you're thinking about they planned database to have a specifically size to store an MD5 hash, so that is the first thing. So they need to change the database. Then the system was in production, a little bit sensitive, so they'll need to do the governance to schedule a change window to change the database. Then they'll need to change the code, verify every time they use a type of username and password, verify it's MD5. Okay, if it matches, then I record the new recommended hash algorithm to store the password. Then they do that for all of the users until, and of course, when you change the system like that, you need to do all the tests, all the regression tests, make sure everything's working fine. Sometimes you need a maintenance window. As you can see, these cost a lot. And those are the kind of things that could have been avoided if they were practicing security requirements since the beginning of the software development. But you mentioned some industry best practice. Where do I find those list of things? It could be a little bit complex, right? Here comes the OWASP, Open Security Verification Standard, or ASVS. This is an application security standard which one could verify your application against those specific requirements that is written that. It's put together by experts, is compliant with some NIST recommendations, with the common weakness enumeration as well, which is well known in the industry, and provides basically 3 levels of verification. Let's call like this verification. And the level 2 is recommended for applications that contain sensitive data. And what is the cool thing about the SVS is they have 14 sections, and they assist you answering most of the questions that you might have. For instance, how should I start a user's password? How should I implement this authentication? Where should I use TLS? What kind of TLS should I use? So this standard answers that question for you. How should I handle the API? How should I handle, for instance, XML? And you can see that it goes a little bit deep into some of those topics and also link that with some other amazing OWASP resources. It also addresses modern issues such as server-side request forgery or two-factor authentication, and even a little bit of IoT. So that would be a great place for you to start bringing this document and bringing this as part of your, when you're writing your requirements, to look into that, because this is based on common threat modeling that applies to, say, the majority of the applications out there. Just for you to give an example, here's the section for the passwords. And you can see 3 items, right? Verify the user set passwords as at least 12 characters. How many times you asked it, what is a good password, right? How many characters? What's the minimum characters that I should have that? Verified passwords, 64 characters or longer are permitted. And then there is that's the reason for that. And it's a good start point because your developers and your team will start basically getting interested, understanding why that's state like this. And then you can make the security requirement as clear as that and very consistent and testable, right? And you can bake that into your user stories. So I put an example here, a user story on Reddit, the user should see a link to user sign-on. So if you're using agile methodology, so the story goes a little bit like this. As an unregistered user, I would like to register myself, then I could start using the application. So it's a very, very simple definition of a user story. And then there will be a bunch of user criteria, of the acceptance criteria. And you could bring those security requirements, you could bring those items from the ASVS and adapt them to your user stories. So as acceptance criteria, for instance, for this specific functionality, you should verify that the user set passwords, at least 12 characters, verify the passwords 64 characters long, and verify the password strength meter is provided to help users to set a stronger password. As you can see, you should make them as clear as possible, as consistent and testable. So when you're building your test on the top of the security requirement will drive your test. Not only the business requirements, but also the security requirements as well. And some of the items are not exactly not exactly non-functional security requirements. They provide functions like how we do a two-step authentication, right? It's a function that you'd be using that. So, and I think this is a great, really great start. And as I said, if you have, for instance, this provide guidance for you how to store users' password. If the company that I mentioned earlier had used that, would be avoided. You know, they should be avoided that MD5 specific situation. So there's the first thing. Second thing that I consider that will help you and start security early, and I put a stamp here as a quick win because I love that, is the dependency scanning process. So likelihood that you'll be using open source components in our solution is great, right? And the OWASP top 10 A9 is using components with known vulnerabilities. That means you're shipping your product with open source components and open source components that have vulnerabilities. So even if your code is completely secure, the open source component might not be completely secure. And there is one report from Synopsys last year, 99% of the code bases audited in 2019 contain open source components, and 75 of those open source components, they had vulnerabilities, and 49% high risk vulnerabilities. So when some open source components like jQuery, Node.js, React, Prime Faces, etc., lots of them that you might be using day to day. So the dependency checking process assists on identifying vulnerabilities on open source components. And the way it does that is by the class of software that is called software composition analysis that can assist you on that task. And this could be integrated into your CI/CD pipeline, could be run on a schedule basis, or integrated with the developer's IDE, which you find even early problems with that. A great project, OWASP Dependency Check, is one of the software composition analysis tool. And the way it works, basically, it attempts to detect public disclosed vulnerabilities contained within a project's dependency. In doing that, it leverages the national vulnerability database from NIST and compares that database on what you have in your dependency. On the screen on the right, on the left, there is a snip of pom.xml file from Maven, and where we specify the dependency check Maven, and then on the right, in the bottom, you see the output as an example. So it found vulnerabilities on the bootstrap minimum, and also on the bouncy castle library. This is specific OWASP dependency check. It scans with its own analyzer, Java applications in .NET, and also leverage third-party services and data sources such as NPM audit and retard.js for some specific technologies. And it's a great win, as I said. Another example, especially nowadays with JavaScript being really popular in React and Node.js and Node Express, is the NPM package manager audit function and the Yarn audit function. So this is very simple to run. You just run them from the command line on a source code folder, NPM audit or Yarn audit. It will check the components that you are using and the dependency of those components as well. And it will bring to you the vulnerabilities and suggest you how you fix those components. This is a great one. Integrates really easily with pipelines. So I put an example on the right. I create a pipeline with 4 stages: check, software composition analysis, test, build, and deploy. And then on the stage check SCA, I run the Yarn audit, and I pipe the results to a text file so I could examine it later. And the cool thing with this Yarn audit and the NPM audit, if they find a vulnerability, they exit the process with a status code other than 0, and this breaks the build for you automatically, which is great. And I think this is, my recommendation for this is start breaking the build with this. If you find that you're using a software vulnerability, you break the build early. So this will give you a time to check this, and it's let's call it like your first security gateway, right? You could also run locally. If you're a developer, you could just run these and fix the things even before commit to the code baseline. And if you are in doubt because, dealing with these terminologies might not be, especially with lack of training, you might be in doubt if this is serious or not. I'll just go to the latest versions of the open source component. And the last of the 3 that I recommend is deploying a static application security testing tool. And this is fantastic because it speaks the language of the developers. So it could catch errors really early in the software development life cycle when are coding, such as hard-coded passwords, SQLite, path transversal, weak cryptography, and hash algorithms. And basically, this will assist you with the verification of the implementation of your security requirements. If you just say, okay, I need to not have secret injection vulnerability. So the application should provide the mechanism to defense. You coded everything, so you could use the SAS to find if those problems are happening or not. It can also be integrated with the CI/CD. It could also be run on a schedule basis and also be part of the ID plugin. I put one example here. I put the list. I'll not name one specifically here. There is a list with the OWASP with a list of them. So the cool thing is it highlights the precise source file and the lines that they have the issues, and provides detailed explanation on the security issues, and in general provides some guidance on how to fix them. And what is the cool thing is that some of the code repositories that are out there now, very popular in the cloud, and they have the free versions of them, they are making the SAS, the open source SAS, of course, available for private projects as well. So definitely you should check this out. I would recommend you to break the build initially. Especially the first time you run this, might see lots of small things. So I would digest everything, how the tool works, because this is a more complex tool than the software composition analysis tool, right? And then you look if there is any false positive or if something is okay. And also recommend you to run more than one SAS if possible. So you could compare, because sometimes, especially the open source, you might have different rules on different products, so you could compare. One might catch one problem, the other one might not catch that specific problem, right? And also, for all the issues you identified, like all the other security issues, I strongly recommend you, especially if you're using a labeling system on your bug tracker or on your issues tracker, you create a label called security, and then you mark that specific issue with that security label. And why do I think that is cool? Because you could have a visibility right away. First of all, you're still feeding the culture of security, right? And you have that label, you could basically select off that label right away security and maybe do a sprint to fix all those security. You could pull all of them pretty easy. So those are the three things that I consider you could start right away, and this would make your software more secure since day one for sure. And there are a few other small recommendations to close this out. And one is get the developers in contact with the application security roles. And the way you could do this, you could use the OWASP Slack channel. Lots of people are discussing that daily. The same problems we've been discussing here, how you do authorization, how you do authentication, how you do security testing. You attend the chapters, local chapters meeting, and look for meetups. And especially now we have lots of meetups online. There's no excuse to not learn about things. Invest on training for your developers. I really like trainings that combine some showcase, showing, hey, this is a real scenario, that specific vulnerability, somebody does this and that, but thinking about a malicious cross-site script and show the impact, and then show the vulnerable code and show how you fix that in the code. And of course, if you could do that, if you could attend those classes, at certain point, and you do something specific to your stack, that's even better. And I would strongly recommend you to start with some free training from the various academies that they are out there. You could start today that. If using public cloud, and probably the small companies, they are moving toward the cloud, right? They are not keeping like a data center, which does not make sense. Leverage the security features from the public cloud, such as container image scanner, secret storage, and even generate SSL certificates for you without paying that because you're at a customer. Automate the repetitive tasks or integrate them with the CI/CD. I think that is the best approach, is the integration. I showed a very simple example that you could do that. And establish the practice among the developers to integrate the code often. That means you're committing the code that you are developing to your code baseline. So when you put the security checks on the CI/CD, this will be running more, and you take the benefit that those security checks will happen early, and you'll be catching errors early. Keep an inventory of your application API and subscribe for vulnerability alerts. Just an example, if you're using Node.js, then you have this application that sits on that specific URL, and then you have the Node.js. Then Node.js, for instance, has a Google Groups that you could subscribe yourself, and every time a vulnerability is out and a Node.js will be out, they will alert you right away. So that's a very, very rudimentary process, but could give you a quick win on getting those alerts. And when hiring an external company for a pen testing, if you're doing prior to the release or because you're compliant, you're making a compliance with some regulations, prefer a hybrid methodology where you disclose with the pen testing company details of the software. You make your developers accessible to the consultants because they will do a better job for sure, than just a simple black box. And even share the source code with them. They'll be able to see things that they might not see during on the black box. And finally, after all of these, lots of things that you could start doing to improve security as your business grows, it's time to plan the next steps. And the next steps basically are related with the software maturity. And the OWASP SAM, the software assurance maturity model, is a great place to do a self-assessment and see what are the activities that you could introduce to your development lifecycle. So thank you so much for having me and for watching this presentation. If you have questions or comments, please send me an email at ismaelrg@gmail.com.